Scientific models are there to be predictive and to explain observations. And when the model breaks down, it's time to move on to something else. Today, you're going to see that we're going to blow some holes into the Lewis model that you've come to accept. In the next slide, 9 examples of where the Lewis model fails to give the expected or observed behavior. For example, perfectly reasonable Lewis structure, it satisfies the octet rule, is this quadruply bonded diatomic carbon. In fact, that's not the structure of diatomic carbon. We know that it has unpaired spins. Similarly, molecular oxygen that you're breathing is a paramagnetic molecule. Would not be represented by that Lewis structure because that Lewis structure, all of the electrons have paired spins. We know that there is a barrier to rotation that is very large for carbon-carbon double bonds, and nothing in the Lewis model explains that behavior. On the other hand, rotation about a carbon-carbon single bond is very easy, but there is a barrier, and where does that barrier come from? That's something that the Lewis model can't explain. The Lewis model can't explain why methyl cation is less stable than this tertiary butyl cation. Not only does it not explain the behavior of carbocations, it doesn't explain the behavior of carbanions. We're going to see many examples where the vinyl anion is more stable than, say, the ethyl anion. VSEPR is another model that's related to the Lewis structure and would predict that that nitrogen should be pyramidal, yet many observations of structures of amides show that that nitrogen is planar. How come? The Lewis model clearly breaks down. In the next example, number 8, the SN2 mechanism goes by a backside displacement. And why is that? What's the reason behind that backside displacement? Similarly, in number 9, why is it that a nucleophile will attack the carbonyl carbon instead of the carbonyl oxygen? The Lewis model doesn't explain that behavior, but we'd like a model that could.